All right, we're going to do lesson 4, unit 1, relations and functions. We'll need to define a few terms, draw some diagrams, and go from there. All right, a relation is defined as a set of pairs of input and output values. So it just pairs up your domain with your range, input and output. Ordered pairs, for example, 1 pairs up with 2, and anything can pair up with anything. 4 pairs up with -6. Let's go -8 pairing up with 1. So set of ordered pairs. You can plot that if you wish, representing that with a scatter plot. So I'm going to use the same data, the same pairs. So x is 1, the y is 2, so there's the point 1, 2. So I'm plotting these 3 points. 4 and -6. So x is 1, 4. The y coordinate is -6. Somewhere down here. And -8, 1. So let's just call that -8 and then up 1. So that's a scatter plot. We can have other types of graphs. We'll be seeing linear ones pretty soon, quadratics in a few months. There's absolute value. Other types of graphs and scatter plots. As a table, you have your x's, your input there, your y's, your output there. 1, 2, 4, -6, -8, 1. So I'm just representing this data, or these 3 points, with a table, scatter plot, a graph, and let's do a mapping diagram. Whoops, put that back. A mapping diagram is, all right, let's fix this. Where you have your input, 1, 4, -8, your x coordinates, your domain, in one bubble if you would. Your output in another one. And you just connect them with arrows. So 1 goes with 2, 4 goes with -6, -8 goes with 1. It's -8. All right, those are the 4 types of representations we're going to be working with. Ordered pairs, tables, graphs / scatter plots, mapping diagrams as well. All right, next definition is a domain. That's a set of all your inputs or x coordinates. So our domain for this table would be 1, 4, -8, this bubble here. Or if you have an ordered pair, it's going to be the x coordinates, the 1, the 4, and the -8. It's not a scatter plot, but a continuous graph of some sort. It'll be the interval covered by the graph. Range is the outputs, the y coordinates, or the vertical interval covered by the graph. So what that means, in fact, I'm going to adjust this one. So I can give you an interval. So let's say this graph runs from, I don't know, an x coordinate of -4 to +5. So the domain for that one alone would be -4 all the way to 5. And we'll discuss in the next lesson how to write this notation properly. But that's what I mean by the horizontal interval. How much space did it cover horizontally from there to there? The vertical interval, let's say that's -2 all the way up to 6. So the range for this one would be -2 all the way to +6. And again, we'll talk about notation on the next lesson, but it's the vertical distance that it covers from -2 to 6. All right, domain is the x coordinates, range is the y coordinates. So this will be your domain, your range, that's your domain, your range, and so forth. All right, definition for a function. So it is a relation. So it's where we're going to pair up a bunch of values. Now, in order to be a function, each element in the domain can be paired with exactly one element in the range. So for every x, it can be paired up with only one y coordinate. So let's see what that looks like. So let's just throw something out. 1, 2, 3, 4. So this one is a function. So the 1 is only paired up with the 2. The x is only paired up with the 4, and the 5 is only paired up with the x. So this one is a function. One way of telling is the x coordinates cannot repeat. So let's say we had this. This x coordinate of 1 is paired up with 2. It is also paired up with 3 right there. It can only be paired up with one of them. The x coordinates for ordered pairs, a short way of realizing it is the x's cannot repeat. And this one is not a function because this x coordinate of 1 repeated on my list. On a table, same thing. If I made a table, we would have 1, 2, 1, 3, 4, 5. So it is not a function. Again, these x coordinates repeated. This x value of 1 is paired up with two y values. The 1 goes with that 2, the 1 goes with that 3, violating our definition. So the x coordinates cannot repeat if you have an ordered pair or table. If it does, it violates our definition. For graphs, it's the same definition, but what it looks like is, so let's say we have something like that. This one is a function. Every point on here has only one y coordinate. One way of determining it is drawing a vertical line and seeing how many times it hits. It cannot hit the graph more than once. So if I tested this one out, every vertical line only hits one time. It is a function. If I had something like this one would not be a function. If you did some vertical lines, it would hit more than once. And let's do a scatter plot. So we had something like this. And let's put those two right here above each other. So this one would not be a function because if we do vertical lines, we're good, but here it hits twice. And right there, if you took out the ordered pairs, or wrote them, let's say, change colors. Let's say this here is at 5, 4, and then this one here is at 5, -2. You can also tell from the ordered pairs that this x coordinate of 5 comes out twice. It repeats. It's paired up with two y values, violating our definition. Graphically, it fails the vertical line test. Cannot hit twice. Mapping diagrams. So we'll have some values. 1, 2, 3, 4, and 5. So 1 is paired up with the 3, 2 with the 4, and let's put this 1 with the 5 as well. This one would not be a function. This 1 is paired up with two y values, the 3 and the 5, violating our definition that says it can only pair up with one y value. What it looks like, you can only have one arrow leaving each value in your domain. And the range is over here. Say we had it the other way. 1, 2, 3, 4, 5. So 1 goes to the 4 only. The 2 goes to the 5 only. And the 3 also goes to the 5. This is a function. And remember, our definition is for every x, it can only go to one y. 3 only goes to the 5. 2 also goes to the 5, but the 2 only goes to the 5. So this one is a function. Okay. All right, last thing for this set of notes is function notation. So we start off defining equations as y equals to something like x plus 3. So then if I made a table, if x was 1 and you plugged it in, so 1 there, 1 plus 3 would be 4. X was 2, plug it in, you would get 5. So we have a function here written in notation with a y and an x. Function notation simply replaces the y with f parentheses x parentheses. You read that as f of x. That's how you read it. And then you put your equation here. And you will just do the same thing. So instead of the y, we're writing f of x, where x is the variable, the letter that you're using in your function, in your equation over here. So if x is 1, we would plug in 1, so then x is 1. So that tells you to replace the x with 1, resulting in an output of 4. If x is 8, so replace the x with 8, giving an output of 11. So x is just the variable. It's just that's what you replace with your domain, your inputs. F is just the name of it. That does not matter, has no bearing on anything other than telling you where to go. You can have G. That's a common one that's used as well. Say 2x. So let's say x is 3. So G of x. So we're going to plug in 3 for x. 2 times 3 is 6. Say negative 2. So x is negative 2. Plug it in. You get negative 4. So function notation just gives you a name of it with f or g or h or any other letter. Has nothing to do with it algebraically. It's just the name of the function. And then the parentheses is where you replace with what you replace with what you want to plug in. You can plug in numbers. Heck, you can plug in other things. I want to plug in z. So then f of z. So all I'm doing is replacing x with z. Would be z plus 3. And we don't really know what z is at the moment, so we can leave it as z plus 3. So you just basically plug in, replace the x with whatever you want to plug in, usually variables and constants. All right, so that's the video for this lesson.